Hello students, in today's video I am going to discuss about the numericals of Raoult's law. Before going on the numerical, first we'll have to see which equations will be used or can be used for the numericals. Raoult's law is applicable for the two different solutions. First one is the liquid-liquid. In liquid-liquid there are three equations which can be used for the numericals. And second solution is solid liquid solution, in which only one equation is used for the numerical. In liquid liquid solutions, three equations are there. First is P1 is equal to P10 into x1. Second is the P2 is equal to P20 into x2. First one is for solvent, second one is for the solute. And P total can be calculated when you sum up P1 and P2, that is for the solution. And in second part, solid liquid, only one equation is there, that is P10 minus P1 divided by P10 is equal to x solute. This P10 minus P1 divided by P10, it is known as relative lowering in vapor pressure, and substitute the value of x solute, that is W2 into M1 divided by M2 into W1. W1 and M1 is used for the solvent, while W2 and M2 are used for the solute. Now we are going to discuss the numericals on these equation based. Numerical number 15 is just given on your screen. In this numerical, we want to calculate the molar mass of the solute. First of all, we'll see what they have given. They have given the vapor pressure of solution, that is 1.004 bar, and vapor pressure of water at its boiling point, that is I have taken 1.013 bar. This is the accurate value of its vapor pressure, but you can take 1 bar. Now mass of solute, they have given 2 gram because 2% aqueous solution is given to you, and mass of the water, that is 98 gram, because we'll have to subtract 2 from 100, so we'll get the mass of water. So according to the Raoult's law, P10 minus P1 divided by P10 is equal to W2 multiplied by M1 divided by M2 multiplied by W1, that I have mentioned earlier. This is the equation for solid liquid system. Just put all the values in this equation. So 1.013 minus 1.004 divided by 1.013 is equal to 2 multiplied by 18 divided by M2 multiplied by 98. Now subtract the value of 1.004 from 1.013, you will get 0.009 divided by 1.013 is equal to 2 multiplied by 18 divided by M2 multiplied by 98. When you making a subject M2, then after multiplication and division, you will get the answer 41.35. So that will be your answer. So molecular mass of the solute is 41.35 gram per mole. Numerical number 16 is just given on your screen. In numerical number 16, we want to calculate the total vapor pressure of mixture. Now, in this numerical, they have given the vapor pressure of these two components, means octane and heptane. Also, they have given the weight of octane and heptane. So, vapor pressure of heptane is equal to 105.2 kilopascal. And vapor pressure of octane, that is 46.8 kilopascal. Now, before going on the calculation, first we'll calculate the moles of these two components, then mole fraction of these two components, then partial pressure, and then we'll sum up the partial pressure of these two components, octane and heptane, and we'll get the answer. So first molecular mass of the heptane, that is 100 gram per mole. From that we can calculate the mole of heptane, that is 0.26 mole. Then molecular mass of octane, that is 114 gram per mole. From that we can calculate the moles of octane, that is 0.31. So first step is over. Now in next step we'll calculate the mole fraction of these two components, which is just given on your screen. Mole fraction of heptane will be 0.456, and calculation of mole fraction that you have already studied in 11th standard. And mole fraction of octane can be calculated when you subtract 0.456 from 1, so it will be 0.544. Now in third step we'll calculate the partial pressure of heptane. This is the given on your screen. P1 is equal to P10 into X1. Now we are having the value of P10, that is 105.2, and X1, that is 0.456. So in next image you will get the answer 47.97 kilopascal. Similar way, partial pressure of octane will be 25.46 kilopascal, and from that in last step we can calculate the total vapor pressure of the solution by sum up 47.97 plus 25.46. So answer will be 73.43 kilopascal. So your answer will be 73.43 kilopascal. Now numerical number 17 is just given on your screen. In this numerical they have given the vapor pressure of water, that is 12.3 kilopascal, and we want to calculate the vapor pressure of 1 molar aqueous solution of non-volatile solute. This is tricky type of sum. Before going on the sum, just recall the definition of molarity. What is the definition of molarity? When 1 mole of solute dissolve in 1000 gram of solvent, then it is called the 1 molar solution. Just use this definition in this sum. So they have given 1 molar aqueous solution, means they have given 1 mole of solute, means mole of solute is equal to 1, and they have also given 1000 gram of solvent. So from 1000 gram of solvent we can calculate the mole of solvent, that is water. 1000 divided by 18, so that is the 55.55 mole, and we want to calculate the vapor pressure of the solution. So use the formula P10 minus P1 divided by P10 is equal to X solute. Instead of X solute I have taken X2. So put the value of P10, that is 12.3, minus P1 divided by 12.3 is equal to 0.0177 mole of solute. You can calculate by the calculation of mole fraction, which you have already studied in 11th standard. After the calculation you will get the value of P1, that is 12.08 kilopascal. So your final answer is vapor pressure of the solution, vapor pressure of 1 molar solution is equal to 12.08 kilopascal.